Okay, welcome to the explanation of the event loop. If you haven't watched What the Heck is the Event Loop Anyway yet, then please go through the link in the description and watch that video first. After you've watched it, come back here. So, welcome back. If you've just watched that video, I'm gonna put our example, the story of the visit to the shops, in the same tool that you saw in the What the Heck is the Event Loop Anyway video, and so we can see what is actually going on behind the JavaScript scenes. Okay, so I'll execute the full example. I'll also put the links to this in the description as well, so you can play with it yourself. I'll execute the full example, but I'll first show what happens to every shop individually, and then we'll put them all together. So just to reiterate the other video, this icon here actually represents the event loop. What the event loop does is whenever the call stack is empty, it picks up the first thing on the callback queue. So this is a queue where different things can be waiting. If there's only one, it will pick that one up. If there's multiple, it will also pick the first one. How does stuff end up on the callback queue? Well, that is taken care of by the web APIs, by the browser. So whenever a timeout finishes or a response returns from a request on the network or a user clicks a button, it will put the callback on the callback queue, and the event loop will pick up that callback whenever or at the moment that the call stack becomes empty. So let's look at what happens when we visit the greengrocer. So here I just have the greengrocer, and where we are going to buy some apples. I've also simplified this a bit. And when I run this, it will put visit greengrocer on the call stack at first. So visit greengrocer is on the call stack, and it goes inside visit greengrocer, and it will call buy apples. And buy apples is on the call stack. And now it will execute what's inside buy apples. And that is an expression and in a return statement. So it first executes this expression, and then it will return that value. So what is really important to notice is this return causes the call stack to return back to the previous function on the call stack. So that's why it's called return. You return from this function to this function, and it removes, well, it actually removes this function from the call stack, and you return to visit greengrocer. So we resume, see that it now has executed this statement, and it is finished executing buy apples, so it will remove again buy apples from the call stack, and then it will remove visit greengrocer from the call stack. Well, first it's the console log, and then it removes visit greengrocer from the call stack, and then we are done. So in this example, we have not used any web APIs. Everything was synchronous. So now let's go from the greengrocer to the cheese shop first. Actually, in the story, we went to the bakery first, but for this explanation, I will go to the cheese shop first. So at the cheese shop, it looks almost the same, except for one extra thing that we also call cut cheese. Well, let's see what happens. So I'll just increase this delay a little bit so better show it. Let's see if I can hit my favorite number. No, it's impossible. Let's go with this. Okay, save and run. Okay, again here we call visit cheese shop, so it gets put on the call stack. Then we call cut cheese, and that also is on the call stack, and actually I've put the delay here a little bit under this 1500, so it will actually go through this loop twice, through this loop. Well, right now it's here, so it's actually calculating the stop time. So it calculates the stop time, and now it goes into the loop to verify that, or it goes into the loop until the stop time is more than the current time. So let's go, resume. So, oh, I don't know why it goes here again. I think this is a little bit of a bug in this tool, but it goes through the loop twice. And then it finished the loop. So this actually took 1.5 seconds now to execute, but after that it's done, so it goes back to visit gshop, and it will do the return the value, and then it will do the console log, and then it's done. Well, it does all the statements separately apparently, but now it's done. So this was also synchronous. We didn't have any web APIs used, and we also didn't have anything on the callback queue. So now for the last example, the bakery, there we did use some web API, namely setTimeout. And let's again increase this a little bit, put it to 2 seconds, 2 seconds this time, a little bit slower, a little bit more delay. That's fine. Okay, now let's run this one. Here again we go visit bakery, then we execute this function, buy bread, and go there, and here you see the setTimeout, and this setTimeout will appear on the web APIs list. Let's see if we see that. Yeah. So right now it is waiting for that 4 seconds that I put in here to pass. After those 4 seconds have finished, have gone by, it will put the callback, so the callback being this function, because that's the callback to setTimeout. It will put that on the queue. Let's see if that happens. 4 seconds passing, and now see, well, it's called anonymous because this function does not have a name. The function that I gave to setTimeout does not have a name. I will just rerun it again and giving it a name, and then see if we can have it with not anonymous, because it's a bit unclear. Let's see, let's go, resume. Now this the call stack is empty, so it executes anonymous, and inside anonymous we execute bread ready callback, and bread ready callback will do the console log, and then we're finished. We just do that one more time. I actually give this a name called, namely timeout callback. So now let's see if we can get it with a name. Put it a little bit faster, because otherwise we're waiting so long. That, okay, let's run it again. Visit bakery. Now we have a name for our callback. This one is now called timeout callback. Makes it a little bit clearer what's happening. So whenever this finishes, well, you can see right now, I've paused it again, but the event loop will pick this up and put it on the call stack, because there's something here and the call stack is empty. Let's go. So a little bit of delay again, and puts it on the callback, or on the call stack. Puts the callback on the call stack, and then it finishes execution, and then we're done. So that was the bakery. Now let's see what happens if we put them all together in one big execution. Let's see what I did. I'll set this one to the defaults. Okay, let's go. Let's run this. So we visit the greengrocer. We do all the stuff at the greengrocer, and then we are finished at the greengrocer. Then we visit the bakery. This will put set timeout. I'll wait. I'll just do this one more time and give this function's names again because it makes it a lot clearer. Timeout callback. Let's see if it here is a bakery. No, yeah, this one has a name, but never displays this name, I think. Yeah, so now the timeout has the callback to timeout has a name. Let's go one more time. We first visit the greengrocer, it will execute synchronously. Then we visit the bakery, which will put the set timeout on the. It will create a set timeout using the web API, and in the background, this is executing inside the browser. And the JavaScript doesn't care because JavaScript is already executing the visit cheese shop here. So we're inside visit cheese shop and we call buy cheese, and we'll do cut cheese, which takes some time. And right now it's really interesting to see that there is something on the call stack, on the callback queue, the timeout callback, because the time has already passed, but we are still executing cut cheese because that takes also a while, 1.5 seconds. So the call stack is not empty yet. So it will not execute this callback before the call stack is empty. So we first, to finish our visit to the cheese shop, and whenever that's done, almost done, now it's done, and now it will execute our timeout callback, and that will call our paired ready callback, and that will do the console log and finish this example. So something that's really important is that if you have some piece of code that will take a while and you execute it synchronously, like we've got cheese here, it will actually block the browser from doing anything. I think it was explained as well in the what the heck is the event loop anyway video. I can show you one more time here. If I do simulate renders here, it will show you the render that the browser is doing. And basically a browser tries to do the render 60 times per second. So every 16.5 milliseconds. But if you have some code that takes more than that time, then it will drop a frame, we call it, because it can't render the frame because your code is still executing. So let's run this and then see that, well, while it's executing code, it cannot do renders. So this is being blocked by our executing code. So now the browser would be unresponsive to the user. And well, let's see when it finishes. Finally, when it finishes, it will do the rendering again. So now it can start rendering again. And if we compare that to our bakery example, where actually this is 4 seconds, well, this takes only 1.5 seconds, so this should be faster. But for the user, this will block, and this one will not block. So if we run this one, again, I'll just put this a little bit faster. And then we run it again. Now, during the time, oh, now I forgot to simulate the renders. Let's do that again. Simulate renders and rerun. So during the time it's waiting for the callback, you can see that it's actually still rendering. And only now it will execute our code. Well, then it's blocked, but that's just because we've put this delay in here, which is artificial. Normally, you can also run it without a delay for one time to show you what happens normally. We just put the delay to 0 and then do rerun. Normally our code is really fast. It's like it's not there. So the rendering will not be blocked. You will not see a red frame here now. I don't know why it's now not executing our timeout callback. This must be a bug in this tool. Okay, I hope that didn't confuse you too much. If it did, then just ask many questions on Sunday, and if you're watching this video later, then I hope there's some good teacher that can clarify it for you. I'll put links to the tools and to some other explanations in the description, because it's always good to have multiple places to find information on a complex subject like this event loop. The good thing is you don't use the event loop in your daily coding life, but it's very important to understand it, to know how your code will behave. Thanks for watching.